Hi, this is Mona. Welcome to my channel. This video is part of my beginners friendly AI playlist. If you're completely new, I recommend watching the whole series from the start. Otherwise, I recommend checking out my more advanced courses instead.
I'll go through 5 modules, each divided into two parts, where I'll cover the key foundational concepts you need to get started. Let's dive into Module 4, Part 1. Today, I'd like to talk about hallucination, but what's the meaning of hallucination is? In psychology, hallucination is a perception without an external stimulus that feels compellingly real. These experiences involve hearing, seeing, smelling, tasting, or feeling things that exist only in the mind. These psychological concepts provide a perfect metaphor for understanding how AI system can generate outputs that seems authentic but don't correspond to reality. If you've ever queried ChatGPT and received a response that reads as perfectly reasonable, yet is completely wrong, well, congratulations. You've just witnessed an AI hallucination in the wild. Those moments can be humorous. For example, Einstein was a TikTok influencer in 1920, or frankly dangerous, as when a medical AI splits out an improper dosage for a perception. And the wild part, the AI doesn't know that it is making stuff up. It just goes on cool as ever. So, AI hallucinations refer to case when AI models produce outputs that are factually incorrect, logically inconsistent, or completely fabricated. Fabricated yet provide a high level of confidence. These hallucinations are primarily linked to generative AI models, specifically large language models or LLMs like GPT, like Cloud, or others. Unlike a bug in standard software, a hallucination is not the result of program's mistake, but rather follows from a model's learned probabilities. Hallucinations range from gentle and inaccurate data to egregious, inventing total legal citations. Understanding the different kind of hallucinations that can be produced is essential to developing a strong validation and testing methodology for AI. These refer to instances where AI models produce output that are incorrect, misleading, or nonsensical. Let's look into different type of hallucination. The first one is factual. They occur when an AI model produces information that is confident or incorrect. This is usually a result of limitation in the training data or the model's inability to check facts. These hallucinations can be specifically dangerous in areas like healthcare, law, or education, where information accuracy is vital. For example, AI says Einstein won two Nobel Prizes while he won only one. The next one is contextual. These hallucinations happen when an AI response deviates too much from the original input or breaks the logical flow of a conversation. Uh, this does produce an output that is still linguistically correct, but it is irrelevant or disconnected from the prompt. This sometimes occurs when the model fails to appropriately preserve previous context. For example, a prompt is, how do I make a chocolate cake? And the response is, chocolate cake is great, and Saturn has many rings made of ice and rock. The response starts appropriately, but it's off topic. The next one is logical. They occur when the model generates a logically invalid answer, usually in tasks that require reasoning, math, or cause and effect relationships. These hallucinations demonstrate that while the AI can imitate patterns, it doesn't always have the logic applied appropriately. In problem-solving scenarios, this could be a huge problem. For example, if John has three apples and gives away two, he has five left. Clearly, the logic fails here. And the next one is multimodal hallucination. It's like mismatches across text, images, and audio generated content doesn't align with a description. Let's move on. AI hallucinations are the result of fundamental limitation in how models are trained and how they generate responses. There are many reasons that cause AI hallucinations. Let's check that out. Data bias or gaps. If the training data contains bias, misinformation, or does not cover certain topics, the model will inherit those problems. This creates a false or biased output, particularly for underrepresented or controversial topic. The next one is probabilistic nature. Language model function by estimating the next most likely word or phrase, not through a process of fact checking, because a neural network is a prediction based mechanism. This often results in confident sounding lies. And the next one is prompt ambiguity. When prompts are insufficiently specific or open ended, the model can misinterpret user intent and produce wrong answers or unrelated responses. The first and foremost step is to write clearer prompts to minimize these hallucinations. Prompt ambiguity is another option. When prompts are insufficiently specific or open-ended, the model can misinterpret user intent and produce wrong answer or unrelated responses. The first and foremost step is to write clearer prompts to minimize these hallucinations. Overfitting and memorization. Models sometimes memorize exact phrases or other outdated information from their training data, regurgitating it without understanding the quality or relevance of that information. This overfitting results in hallucination that sound factual but are actually out of date or incorrect. The effect of AI hallucination can range significantly depending on how the specific model is used. While many hallucinations can be harmless or useful, particularly in creative industries, others can be quite dangerous and damaging to credibility. This is especially true in critical industries where adoption is slow. Let's look into more details. Low risk domains. In domains such as entertainment, narrative, or creative writing, hallucinations can be deliberately or usefully introduced, and AI generated information that doesn't adhere to facts may facilitate greater creativity, world building, or artistic expression. For example, a real use case would be an AI written fictional short story that adds imaginary planets or magical creatures. High-risk domains. In fields like healthcare, legal, or financial, hallucinations can lead to real-world damage. Inaccurate information could cause medical errors, legal misadvice, or financial losses. with potentially life-threatening or legally serious consequences. For example, an AI prescribing the wrong dosage of a drug or quoting non-existent law in legal advice could have disastrous consequences. So, identifying AI hallucinations helps make sure the output is trustworthy, which is important for crucial applications. There are several ways, both manual and automated, to check whether an AI generated response is true or false. The detection strategies include manual review. It requires human specialists to access the result of AI for completeness and correctness, which is essential in domains like law, medicine, or science. Though it's slow and tedious, it's one of the most effective means for spotting hallucinations. Automated cross verification. AI responses are all compared to structured knowledge bases like such as Wikipedia, Wolfram Alpha, or Enterprise Database to identify inconsistencies. This method allows for the quick flagging of mismatched facts. Retrieval Augmented Generated or RAG. With this approach, the model retrieves relevant documents before generating a response, with its output grounded in those sources. This makes a big difference by localizing hallucination risk to real evidence, anchoring responses in it. Just a quick reminder, I'll explain RAG in detailed in separate video in Module 5. And the last one is fact-checking APIs. These are tools or services like Google fact-check tools or claim review and etc. used to auto-verify AI statements based on fact-checking databases. They are direct injection into the AI pipeline a query input for instance validations. Okay, hallucination mitigation begins at the model design level and involves integrating data structure and safeguards into the model with care. They improve the factuality and reliability of AI generated outputs. RAG or Retrieval Augmented Generation combines a language model with a retrieval system, pulling relevant documents or facts in real time, in real time to ground the output of the model in real world data. That greatly limits the risk of hallucination by linking responses to verified sources. Fine-tuning with factual data. Training or fine-tuning the system on curated factual databases reinforces correct information and discourages memorization of false information. This improves factual accuracy and reduces generalization errors. Prompt engineering. Structured and relevant prompts frame the model correctly to understand ambiguities and the risk of hallucinations at the same time. Equally, prompt constraint may also reduce the range of the answer to only what is knowable. Use of confidence threshold. The model generates a confidence score associated with each response, allowing it to either highlight or refuse answers when its confidence is not high. Those low confidence outputs can then be human reviewed or supported by further verification systems. I'd like to mention best practice for QA teams. QA teams are key players in testing that AI system yield factual and trusted outputs. These best practices expose an additional layer of model reliability, and when properly integrated into the development lifecycle, can help incrementally improve model performance over time. One of them is develop a hallucination testing checklist, like build an AI output evaluation checklist to test accuracy, consistency, and contextual relevance. This allows for a standardized approach to hallucinations detection across projects and releases. Integrate testing in CI/CD pipeline. Introduce hallucination detection as a part of your continuous integration and delivery process. It does enables automated validation on model updates and prevents a regression before deployment. There are other options like label datasets for truthfulness and automated comparison and so on. If you'd like to know more about them, please let me know and drop them in the comment. We discussed in the last video about perception prompting elaborately. Let's talk about parameter tuning. In some cases, AI behavior is adjusted through key settings and you can manage them. Temperature and topic, let's look at them. Temperature is related to creativity. In fact, it controls how low creative or precise the model's answer are. And a low temperature like zero point 0.2 means the model will give more predictable, consistent answers, and high temperature like 0.8 or 1 means that the answer will be more creative and varied. However, bear in mind, high temperature often leads to hallucination. Topi is related to originality. It's another way to control creativity, but instead of randomness, it looks at the probability of the next word. And a low top means the model will only choose from the most likely words. A high top P means it can also pick less likely words, making the text more diverse. I mentioned in details in previous video when I was introducing Prompt Hub website. If you like to know more about it, you can watch the video. And as you can see in this diagram, we can say that how temperature setting can affect to the results. Yeah, let's move on. Before starting part 2, to wrap up, I would say that AI hallucinations are an inherent byproduct of how generative models work. While they may be tolerable in low-risk contexts, in regulated or mission critical domains, they demand rigorous testing, monitoring, and preventing mechanism. Through a combination of human in the loop validation, automated tooling, and improved model grounding, hallucinations can be significantly reduced. As AI becomes ubiquitous, testing for hallucinations will no longer be optional. It will be fundamental to delivering safe, reliable, and ethical AI systems. In the second part of this video, I'd like to talk vector database. When we use AI, it's important to understand some core concepts. Indeed, vector database is one of the key concepts that you should know about it if you want to learn RAG fine-tuning or continue to learn and work with AI professionally. Let's go through it. So be sure to keep going with me. Meanwhile, if you found this helpful to hear, don't forget to like and subscribe. And if you have any question, drop them in the comments. I'll be happy to answer. When we search for a white cat on Google, the system doesn't just look for files named cat.jpg. Instead, it finds image that means white cat, even if the word cat isn't in the file name. This ability to search and understand meaning comes from something called the vector embedding, and they are stored and managed inside a vector database. Why this matter? Because it's for future topics and it's a foundation of modern AI. Understanding vectors and embedding is essential before moving into generative AI, which uses embedding to understand context and create new content. And agentic AI, and also agentic AI, because it uses vector to reason, plan, and interact meaningfully with its environment. You can think of a vector database as the memory and understanding systems of modern AI. They help AI remember, compare, and make sense of the world. So let's move on. A vector database is a special kind of database, kind of database built to store and search through understand data, things like text, image, or audio by using vectors. I mean mathematical representations of meaning. Traditional databases stored structured data like rows in a spreadsheet, including numbers, names, dates, etc. But AI systems often work with messy, complex data like a sentence, a sign, or a picture that doesn't fit neatly into tables. That's where vector comes. So, what is a vector or embedding? I said that data comes in various forms, from text to image to videos and audio. Today's AI models are trained on and designed to handle this increasingly unstructured data. Vector databases bridge the gap by converting these data sets into mathematical representations called vector embedding. This allows for efficient storage, retrieval, and manipulation of unstructured data. Vector embedding is what makes these databases highly potent for working with unstructured data. As stated above, these vector embedding are an array of numbers that are generated through embedding or machine learning models. This image below demonstrate how it works. And as you can see, we have something like this, or even this one, and also this one. I illustrated this website in previous videos, and as you can see, this is the vector, and it's a 3D vector, and there are lots of words that you can find how they are near to each other. Let's move on. So how are embedding created? Embeddings come from embedding models, AI models trained on large data sets to understand the different kinds of data. Like text models like Word2Vec, Glowy, or OpenAI's text embedding models. And images models like Clip, and audio models like Wave2Vect. These models learn pattern and turn each input into a vector that captures its deeper meaning. Behind each of them, there is a complicated algorithm and tons of mathematical calculation. Pinecone is one of the best vector databases in 2025. It is a cloud native database tailored for application that involve the large language models. It offers simple API for Python, JavaScript, TypeScript, and REST API to make it easy to developers to integrate it with different programming language and frameworks. If I go through to this documentation about vector database, you can see that there are some algorithms. If you like to know more, you can go there and read here. Let me show you. Yes, as you can see, there is a documentation here, and you can read more about what is a vector database and what's the difference between vector index and vector databases, and go through and watch the pictures here to understand better. And yes, let's move on. Yes. Why use a vector database? A vector database organizes these embeddings so we can search by meaning instead of keywords. For example, find image that looks similar, search documents that talk about the same idea, or match user queries with the most relevant responses. It's like having a super organized library that understands the concepts behind your data, not just a word or file name. And as I showed you here, let me show you. Yes, here, this is a real world uses. Vector database are the heart of many AI systems like search engine, Google, Bing's, and chatbot and RAG systems like ChatGPT, Perplexity, and recommendation systems like Netflix and Spotify, and image recognition and tagging tools. So let's wrap up. I explained embedding as the number that represent the meaning of data, and vectors where these embeddings live, and vector database systems that store and find vectors efficiently. And we talked about why it matters because without them AI wouldn't understand context or similarity. Thanks for watching. If you find this helpful, don't forget to like and subscribe and share with someone who might be interested. See you in the next video. Take care.